An introduction to summation notation. So the goals here, understand summation notation and be aware of the different closed forms to evaluate certain types of sums. So starting out, let's just look at what summation notation is all about. And basically, they use the capital Greek letter sigma. This little thing here looks like a sideways M or something, but that is a capital sigma. And what it means and indicates in math is sum. So you're adding things together. What are you adding together? Well, you're adding a bunch of different terms together. So this is the ith term. And if it's a function, then you're going to plug in some I values. And the way this I value will work is down below here. You see this I. This is the index. Now keep in mind they use different letters sometimes for the index. Sometimes you'll see a K. Sometimes you might even see the N being the index variable. But here you're going to see I. So I is the index. And they started out down below with some value. Here we have just generic A for the starting point. So this is the starting I value. And typical ones are 0 and 1, but you could really start this anywhere. Start the I at any number you choose. And then up top, you have the ending number. In this case, we just go all the way up to N. But if it was actually a number, that's the highest number you would go up to for I. And as you plug in I's, or as you go through the different I terms, every time you increase the I value, as you move from the starting to the ending value of I, you will put a plus sign as indicated by the summation. And then you add all those values together to get the final result. So that's pretty much all there is to the notation. You have the symbol indicating you're adding things together. You have what you're going to add together, the ith terms, and then you have an indication of where I will start and where I will end. So one thing that's going to be useful for what we're going to be doing in calculus is this idea of having a closed form of a summation. And basically what this is something that allows you to, instead of writing out all the terms with plus signs in between and then add them all together, you can just plug in the N and get to the final answer. So they call this a closed form, and you can avoid expanding the sum and adding up every term. So this is really helpful if N is large. If N's like 100, you don't want to have to write out 100 terms and add them all together. You want to just use the formula, the closed form. So some common closed forms that you're going to see would be like this one here. You got I equals 1 to N of C. C is just some constant. So you would just be able to take that constant times N in order to get to the answer. And in an example here, if you take a look at this, just kind of put some context. If you had I equals 1 to 5, so we start at 1, go up to 5, there's basically going to be 5 terms here, and we just have the constant 2. Well, the first term is just 2, because, well, there's no I there to plug anything into, so you just take it as 2. After you write the first term, you put a plus sign because of the summation. The second term, well, still no I to plug in, so it's just 2 still, it's a constant. And then plus, and then the third term is a 2 as well, and then the fourth term is a 2 as well. Now I'm up to the fifth term, the last term, and it's also a 2. You add up all those 2's, you get 10. Now, using the closed form, the C times N, notice that the N here was 5, the C was 2, so we could just take 2 times 5 and get 10 and be done. So closed form versus expanded form. Closed form, even with the small number of terms here, is quicker. Right, so the next one here, if you're adding up all the i's in between 1 and n, you can get the total sum by just doing n times quantity n plus 1 over 2. So let's see an example of this. And in this case, I'm just going to do I equals 1 up to 4 of the sum of those i's. So when I is 1, you just put a 1 there because that's what I is. And then plus, then you increment I up to the next number, 2. You always increase by 1s here with these index values. So I is now 2, so I just plug that in, and now I got 2. I jumps up to 3, and then lastly I will be 4. And if you add all these together, just in a coincidence compared to the first one, you get 10. The other way to do this, using the closed form, would be to say, okay, my n is 4, and I'm going to do 4 times 4 plus 1 all over 2. And if you simplify that, you get 20 over 2, or 10. And this is much nicer, especially if you were adding up all the numbers out to maybe, I don't know, n is 1,000. It'd be much quicker to use the closed form than it would be to expand out the sum and add all those terms together. Okay, so that's 2 nice ones. Let's take a look at 2 more. So we have I squared. So you would take all of the numbers in between 1 and n, square all of them, and add them all together. Well, you could do that, or you could just plug in the n into that closed form, n times quantity n plus 1 times the quantity 2n plus 1 all over 6, and get to the same answer. So let's take a look at an example here again, where I am going to go from I equals 1 to 3 here for I squared. So we're going to have 1 squared, then plus the I goes up to 2, and we'll square that, and then plus I goes up to 3, the last one, and we'll square that. And you'll get 1 plus 4 plus 9. You add all those up, you get 14. That's nice, but let's see what this is in the closed form. So n is 3 here. So we're going to have 3 times 3 plus 1 in the quantity times 2 times 3 plus 1 quantity all over 6. And you're going to get here 3 times 4 times 7 all over 6. And if you reduce that down, you get 14. So again, imagine if n was like 50. You don't want to do 1 squared plus 2 squared plus 3 squared plus 4 squared plus blah, 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 49 squared plus 50 squared. You don't want to do that by hand. You want to plug in 50 into the n into this nice closed form here. You want to use that. Much easier. So then the I cubed, last one we'll look at in this introduction video, and similar concept as I squared. You're going to take all the i's, cube them, and then add them together. So let's go ahead and take a look at an example here. So we'll have I equals 1 to 3, just using a small number here. I cubed, so we'll have 1 cubed plus 2 cubed plus 3 cubed equals 1 plus 8 plus 27, and that ends up being 36. Not too bad, but again, this is something you got to imagine. If n was a really big number, then you're going to be writing for a long time, and it's going to be much easier to just use this thing. So again, n here is 3. So we're going to have 3 times 3 plus 1 in the quantity all over 2, and then that whole quantity squared. And what you get out of this would be 3 times 4, or 12 up top, over 2 squared. 12 over 2 is 6. 6 squared gives you 36. So much quicker. Again, even with smaller numbers, it's useful to know these closed forms. So we'll see these being used in other ways moving forward, but hopefully that introduction gives you a decent idea of how these summation notations work and some of the closed forms that you can use to avoid the painstaking process of expanding out large amounts of sums and adding them together by hand. Thank you for watching.